In this video, I'm going to walk you through how we can make slightly better sounds with our Arduino Uno. So up until this point, to create sound and music, we've just used those tiny little piezoelectric passive buzzers, which don't have a great sound because we're just pulsing them with what are known as square waves, just quick pulses on and off of our digital pins to create a sound. So we're able to make these singular tones, but they don't sound great. And what I want to do is show you how, with using an Arduino Uno and a serial port, we can just create basically an infinite combination of sounds. And so the way that we're going to do that is with MIDI, or Musical Instrument Digital Interface. MIDI is basically a communication standard for how different sorts of digital instruments and interfaces for digital music can communicate information back and forth. It sends information about like the specific note that's being played, the intensity with which the note was being triggered, and all sorts of different things to be able to trigger samples, synthesizers, anything like that. And so basically just with this, we can create like an infinite different combinations of different sounds, and you can create some pretty cool instruments. So this is going to be a brief crash course in doing MIDI with a serial interface on an Arduino Uno, and I might build upon this later. But let's go ahead and jump into the code here. So I've started here with this basic structure. There are two functions that you need to bring into your environment here to turn on a note and then to turn off a note, and basically have like a rest to pause for some duration of time. There's also this notes.h file, which maps all of the different notes to the corresponding all the notes on the piano to a corresponding MIDI decimal value. So this is like A0, the first A on the piano. This would represent A sharp. This would be B, C, C sharp, and so on, where these numerical values kind of indicate what octave they are a part of. And it kind of very easily maps these values to these decimal values, so we don't need to remember the specific MIDI code for that key. We can just use these more intuitive names when we're creating a sound. And then here, what we need to do is include notes.h up at the very top so that we can use these pound-defined macros in this environment. And then you just need to paste these two functions down at the very bottom here. So they are note on and note off. So note on takes the note value. This is some integer value that is one of these values here. There is the velocity, which is some value between 0 and 127. That corresponds to like the intensity or how forcefully a note is being played. I guess this should say note. And then there's the duration, which is the number of milliseconds we want the note to be played for. And so a MIDI packet of information basically typically consists of three different parts. The first is the command, and so the note on command corresponds to a hex code of 0x90. And what I mean by hex is like a hexadecimal number. So hexadecimal numbers can be easily converted to decimal values using any online converter, or you can do it by hand. But basically, a hexadecimal value of 0x90 corresponds to a decimal value of 144. A lot of times MIDI documentation will just use these hex values. I was just using these decimal values in here because that's what we're familiar with, but I could just as easily say 0x90 or 144. It would do the exact same thing in code. This 0x just indicates, hey, the numbers that follow are going to be hexadecimal as opposed to our standard decimal. So I'll just leave it like this for now. And then what we'll need to do is we are going to send this MIDI information to the computer using the serial port. That's what all these serial write commands are, is they are writing each little piece of the MIDI command one by one to the computer. So what we'll need to do is set up the serial port. So I'm going to say serial.begin, and then we're going to use a slightly different number here. This is the speed with which we are communicating from the Arduino to the computer. This is something known as the baud rate, or how many different bits are being sent per second. And so we're going to use 11,5200 here, or 115,200. And so I'll show you why that's important once we actually start to connect it up to something. But this is what we're going to do. We're going to do that for our setup. And then just to kind of test to make sure our interface is working correctly, what we'll do is we will just call note on, and we could just call it for a single note here. I could just say, let's play, I don't know, let's play something, our middle C, right? So that would be like C4. So I could say note underscore C4. And then I need to tell it its velocity. So we'll do something right about in the middle here. So the maximum values are between 0 and 127 for the velocity, or the hexadecimal values are 0 through 7F. So like right in the middle would be like around 63. So I'm just gonna do right in the middle. And then for the duration, I'll just say play that note for like half a second. And then what I could do is I could call the next function here just to turn off the note. So I could say no note, and then we'll just do another duration of 500 just to see if this works. Okay. So now what I need to do is I need to upload that information, or this new program, to my Arduino. It's compiling, and now it's uploading, and now it's done uploading. So I could pull up the serial monitor here and I could see this information start to come in, but it looks like a bunch of garbage. And so what I need to do is I need to change the baud rate right here to match the new baud rate that we use. So that's the 115200. And if I change that, we should see this information start to come through, but it still looks like gibberish because these are MIDI these are MIDI commands. These aren't things that are meant to be interpreted as normal, like plain English here. And so what we need to do is route the information that is being sent from our Arduino to some sort of audio interface. So what's important is that I need to close the serial monitor because now something else is going to be reading this Arduino information. And so we're going to need to use some combination of different programs here. So I'm going to pull this up here. The first program that you'll need to install is this hairless MIDI to serial bridge. And so you can find this just by searching it up or going to this URL, and you'll download it for your operating system. So I've already downloaded it here for Windows. And what I'll do is I will pull it up. So this is what it looks like when it's pulled up. Sometimes it might crash when you open it. If your Arduino is actively sending messages, so sometimes I have to hold down the reset button while I'm opening it up. But right now it is opened up, but it is not connected until I click this checkbox here. I'll also need to make sure that I've selected my Arduino Uno in this dropdown, and then once I do this, it should start to receive those messages. So if I click this, we see it start to blink here as new MIDI messages are coming in. If you're not seeing this, what you can do is you can turn it off for a second, go to Preferences, and make sure that your baud rate is set properly. So it should be that 115200 that we set in the program over here. So these should just be in agreement. So once you've done that, you can try and turn it back on and see if it sends that information back and forth. So it is successfully sending it or receiving that serial information, and then it's going to send it out as some MIDI information that I could then bring into some like digital audio workstation to be able to play different sounds. And so that's the next piece that you would need to install. You need to install something called Loop MIDI, and that is available here on this site. This is specific to Windows. There are other ways of going about doing the same thing on Mac and Linux, but this is the Windows specific version. So you would download this and then launch it, and then what you'll need to do is click here. Actually, we can go through this process. So let me go back to the hairless MIDI, and I'm going to stop that. So let me remove this. If I hit this plus button here, it's going to add some port. I can then select that port here from the drop down and then turn it on so that it receives in that serial information and passes that along to this Loop MIDI port. So it helps it act like a device that I can route to my computer and pull up in some like audio recording software. So instead of pulling up audio recording software, what I'm going to do is just pull up something that acts like a digital synthesizer, because what we're doing is we're sending note information from here and we can use that to play the synthesizer. So there's a few different options here. The first thing we're going to take a look at is this online synthesizer. So you can go to this URL and just come here and hit load interface. And you can see it's now playing my note over and over and over again. So I'll bump up the audio just slightly so it's hopefully not too loud. But there it is, it's just playing our note over and over again. Another option here, let me refresh this so it stops, is this program called Helm. This is a free and open source synthesizer software that's available on most operating systems. So I'm going to pull up mine here and run that. So Helm, there we go. There it is. Okay, and so there, it's receiving my information, my C note here that I'm playing in over and over and over again. And there, now you should be able to hear it a little bit, and I'll bump that back down. So that's great. Now to stop it, what I will do is I'm going to mute this for a second, and we're going to go back here. So if you're ever just getting annoyed with it, you can toggle this on and off just like that, and that would make it work fine. But let's go into our program here and try and spruce it up a little bit, because right now we're just sending that single C note just over and over and over again. And so let's try to make it do something a little bit more interesting just to close out this example. So instead of doing a C note, right, because remember that's just mapping to one of these random or these decimal values here, our notes could be any number between 0 and 127, with the piano notes being between 21 and 108. And so what I could do is try to have it randomly generate some note that's kind of around the middle of the piano here. So let's say like between like 60 and 80. So in Arduino, there is a random function that is provided for us. So what it does is it takes two values that are going to be like the start and the end of the range here. And so this is the first possible value it could be up until the last value, but it doesn't include that last value. It's inclusive of this one and exclusive of this one. So basically it would randomly generate some value between 60 and 80. And then this right here is going to correspond again to my velocity, or the intensity with which the note is being hit. And then to kind of randomize the time that is spent on a note, what I'll do is I'll say, okay, generate some random value between 2 and 6, then multiply that by 100 to kind of make it either like 200 all the way up to 500 milliseconds. And I'm going to turn off this no note option here, and I'm going to upload this new copy of the program that should do something a little bit more interesting. And this actually brings me to a very important thing that I wanted to highlight, is because the hairless MIDI is using that device, it's reading in those serial messages, I can't open it and I can't send a new program from the Arduino until I disable it over here. So if I come over here and I toggle that off, I should now be able to upload my new program. And so that's going, and then once it's done uploading, I can turn it back on. So there it goes. I'll do that, and I'm going to bring back up Helm, and we can see it's kind of randomly playing a bunch of different notes here. So let me turn this up a little bit, and there you go. You should be able to hear the notes coming in. So it doesn't sound great, but it does kind of help show, you know, some of the possibilities here, right? I could dial in and change all the settings here and make it sound exactly the way that I wanted to, and just interpret this information. So it could sound like a piano, a guitar, a violin, like any sort of instrument, you know, that does or even doesn't exist. You can cater the sound to be whatever you want it to be. So it allows you a lot more control and allows you to be able to make sound that's a lot prettier than a little speaker. And then to kind of round it out, what you could do is actually create a full-fledged instrument using all of your digital and analog inputs here to create something where the Arduino can read whether or not some switch is pressed or whether a dial is turned, and use that to influence what note is being sent to the computer here to play, you know, certain notes and influence the particular sound. So the possibilities are really endless, and you can really do some really cool stuff. So maybe we'll do some more with that in the future.